Morning, everybody. Thanks for coming along. I thought I might kick off 1 minute early, just give you an extra minute, and then burn it by talking about how I'm giving you an extra minute. My name's Damien Brady. Today, I am going to be talking to you about DevOps, where to start. And so the first question I got from somebody was, is this specifically .NET or specifically Azure DevOps or anything like that? And the answer is no. This is completely ambivalent of tech. This is ideas about where you can go next in your DevOps journey, whether you're just starting or whether you're halfway through and doing well and just looking for the next thing to do. So it's very generic and it's very high-level kind of advice. So as we go through, I'd like you to think about your current situation and think about whether any of these tips and suggestions resonate as we go through as well. And these can be suggestions for what to look at next. So DevOps has a lot of definitions. At Microsoft, we define DevOps as the union of people, process, and products to enable continuous delivery of value to your end users. Now, the bit that I want you to focus on here is value. So we're not talking about continuous delivery of features or continuous delivery of tasks from your task board. We're talking about continuous delivery of value. And value is the most important thing when it comes to DevOps. If you are just pushing features out the door and then forgetting about them as soon as you've finished putting them in production, then you don't know whether you're delivering value. So having that feedback loop is super, super important. And this really comes down to focusing on the customer or focusing on the end user. Is what you're doing valuable for that customer, for that user who is using the application? Right? So that's where your focus needs to be initially. The other definition that I keep seeing of DevOps is all about how DevOps is not a process. It's not a set of tools. It's nothing like that. DevOps is a culture. And I think that's true. This is a really popular opinion, by the way. That's just a Bing search for that phrase specifically. I agree with it, but I also think it's not terribly useful if you're an organization trying to get started with DevOps. If you've ever been somewhere where they tell you your culture has now changed, that's not really how it works, right? So what you can do is you can encourage certain behaviors and certain practices and discourage others, and that can lead to an improvement in culture. You can't tell people to change the way they feel about things. So DevOps is a culture, sure, but that's not necessarily where you can start to actually make change. So the other piece of advice here is that rather than doing everything in one hit, so don't stop work, try to automate the whole thing to get a DevOps process in place. Find what hurts the most in your organization and fix that. And the stream of people, by the way, there's a book over there as well. I believe Jeffrey has some plenty at Build as well. So the Azure DevOps booth, I believe, has a ton of them as well. So if you miss out now, there's plenty more around. But keep going. So I said that this was going to be general advice, and it is. But I thought a nice way of kind of categorizing the different tips and the different things that I'm going to be talking about is to actually look at the product, Azure DevOps. So I mentioned before that DevOps was about people, process, and products. You can't just you can't just start using Azure DevOps services and that fixes everything. But the tools in Azure DevOps, the services in Azure DevOps, are really good for categorizing the kind of changes that you might want to make in your organization. So this is how I'm going to structure this, with some tips around these things. And some of these you may be implementing really well, some of them you may not be. But this is a nice way of categorizing them. So let's start with Azure Boards, which is the Azure DevOps service for managing your work. What work you're going to do next, what work's been done, the bugs, the tasks, the epics, all of that kind of stuff. And this is really what I was talking about, where this needs to be based on the customer, right? If your work planning is based purely on the requirements that somebody who never speaks to the customer thinks you should implement, then you're likely to be implementing the wrong thing. Right? So you really need to be focusing on the customer. And to do that effectively, you actually need to talk to the customer. So this is something that the Azure DevOps team itself puts into practice. There's no layers of support and layers of communication between the developers writing the code and the customers using that code or the users using that code. If you have these layers of communication, these are barriers, and it means that by the time the developer actually gets that request, you don't know really what was being asked for anymore. That can be solved with a phone call, with an email, with some direct customer communication. So don't put these artificial barriers in place. That reduces communication, and it means the work that you're doing is less likely to be valuable. So direct communication with the customer is really important. The other thing that's really important is actually working out whether the work you're doing is valuable and pivoting away from it if it's not, and pivoting towards the stuff that is valuable. And this is all about experiment-driven requirements. So this is a concept that is deeply uncomfortable for some organizations, where they start doing some work, evaluate whether it's actually solving the problem it's supposed to solve, and if it's not, moving in a different direction or turning that feature off. This works quite well with other techniques like feature flags, where you can roll out a version of an implementation or a version of a feature, and if it works, that's great, you keep rolling it out to everybody else, and if not, you roll it back or you turn it off. This allows you to actually test things in production, which sounds like a bad idea, but testing in production is the only way of testing whether something is actually valuable. So in Azure DevOps itself, if you logged in and you click on your name or your profile photo up the top left, there is preview features. These are all feature flags, and this is what we're doing. We're experimenting with these new features, and we have metrics around these features to determine whether our guesses about whether this is going to be valuable are actually true or not. So we're not just pushing features out and assuming they're going to work. We're pushing features out a bit at a time and making sure that our assumptions are correct. We're actually delivering value. So these are just little tips about how you can plan your work a little bit better. So let's move on a little bit more technically, and we'll talk about not Azure Repos, but Azure Repos is where we keep our source control. And I didn't put a bullet point for this, but it goes without saying, everything should be in source control. Your code, your infrastructure, definitions, the way you build that infrastructure, your build definitions, release definitions. Thankfully, Azure Pipelines now allows you to put your release definitions in YAML alongside your code as well. So all of this stuff should be in source control as well. So starting from that, there's a few techniques that are really, have really been shown to be valuable in a good DevOps organization. And one is trunk-based development. So the short version of this is that everything that is eventually going to get to production should be on your trunk or master branch, or at least one main branch. So rather than having a dev branch for the work that you're doing and then merging that back into a QA branch and rebuilding it and deploying that, and then a master or production branch and rebuilding and deploying that, if you have this one trunk, it means that you are pushing code to this main branch constantly. It means that that main branch needs to be healthy, and that there's one artifact, one build that you push all the way through your environments to get to production. So by the time you get to production, you have tested that build, that code that everybody has been working with so much that it's very likely that what goes into production is going to work. There's a few things around this theme, but trunk-based development is a really good way of trying to work. Trunkbaseddevelopment.com is also a fantastic place to go to have a look at all of the arguments for and against and why it actually results in good outcomes. And there is proper research behind this as well. It's not just people's opinions. So to do this effectively in a larger team, it doesn't mean don't branch at all. It doesn't mean everybody push directly into master. You can have feature branches and branches for different parts of code, but try to do them as short-lived feature branches. Anything longer than a few days in a feature branch starts to drift away from what the master looks like. And so you have 5 teams working on different sets of code, and then when you merge, you get this merge hell. And it's really, really difficult to put things together, right? You want to merge as early as possible. So short-lived feature branches that come back in. One of the other tips I'll give you as well is this whole idea in DevOps of shifting left. So if you think about your pipeline as an idea through to writing the code, to building, running tests, deploying it, monitoring what's in production, as kind of a left to right, it's much, much cheaper to fix an issue that you find as far left in that pipeline. If you find a bug on your development machine, that is way cheaper to fix than finding the bug in production, right? So shifting left can work this way as well. So pull request checks and pull request policies or branch policies mean that you can run a build before the code from your team actually even gets into master. You can make sure that the code that people are submitting is not going to break your build. You can run whatever stuff you want in that pipeline as early as possible, and that will alert you to problems much, much sooner, which makes them cheaper to fix. So shifting left and moving as much stuff as early in the pipeline is really handy. So pull request validation is really important. And then some of the technical things you need to do, you may need to start refactoring some of your code to enable this stuff. if you try to get everybody in your organization to work on your master branch right now, that's likely to be very difficult, especially doing short-lived feature branches. Everybody knows maybe there's a week's worth of work in something or 6 weeks worth of work in something. You don't want to break the master branch while that work is happening, but you also don't want to keep a branch separately from master while that work is happening. So refactoring such that you can keep writing code against that master branch without breaking things. Abstracting things away and writing a new implementation rather than writing over the top of existing code. Having feature flags that point the code in one direction. So you deploy to production, pointing it at the old code until the new code is ready, and then you try and flick it over and see if that works as well. That can require a few changes in your architecture of your application too. All right, let's move on from the code and let's talk about continuous integration, continuous delivery. So Azure Pipelines is the tool that you've probably heard about a few times at Build so far. This is all about building your application and then deploying it in an automated way as much as possible. So the key here, and this is something that I really try to get everybody to do, is deploy as frequently as possible with as smaller changes as possible, as small changes as possible. And the reason is, if you have 6 months worth of work that you're deploying all in one hit and something goes wrong, what went wrong? And even if you do identify what went wrong, if you go to a developer and say, remember that code that you wrote 2 months ago? There's something wrong with it. I don't remember what code I wrote 2 months ago. I don't remember what code I wrote this morning, right? So if you can release these things as soon as possible, there's 2 advantages. One, there's less risk because there's less change. You know? If something goes wrong, it's easy to identify what it was and easier to identify what fixes it too. So smaller changes means smaller risk. And faster delivery of these changes means if something does go wrong, you are already on a cadence where you can fix that and push it out really quickly. So rolling forward is much, much easier, fixing the bug and rolling forward. This means having test environments in your pipeline as well. So if everything is on your master branch and everything gets deployed really, really quickly, you want your pre-production environments to be relatively accurate in terms of, is this going to work in production as well? So having test environments that look nothing like production is not very valuable. So having test environments means that you can check that things go wrong before you hit production. So a failure in staging is not a failure. It's a success because it didn't break in production, it broke in staging. So having these environments is really important. And some kind of automation as well. And this is a tricky one. People try to automate absolutely everything. And I think you should. That should be your aim. But don't stop doing DevOps. Don't prevent any movement forward until everything is automated. So find something that is difficult right now, automate that. Then find the next most difficult thing and automate that. And eventually you'll get to a point where everything is automated. You might still want somebody to click the button to deploy to production, but the deployment to production will actually succeed because everything is automated. So finally, the other tip I have around here is the idea of idempotent deployments. So this, at its basic level, pretty much means that if something goes wrong halfway through a pipeline or halfway through a release, you can just hit deploy again, and it'll try it again. It doesn't matter if something fails halfway through, it just means that you can start again. You can do it in one hit. I've been in plenty of organizations where a deployment fails halfway through. Maybe there's some problems with disk space, maybe a folder was locked or something like that. And you have to kind of work out where you are in that deployment, because you're just deploying a patch. What SQL scripts have been run? What files need to be copied now? Like, is something corrupt halfway through? It's much, much easier if you can get your builds and deployments so that they're idempotent, which means if something goes wrong, you can find out what the issue was, fix it, and just hit go again. So that's a worthwhile aim as well. All right. The final part of this is, sorry, not the final part, second final part. Azure Artifacts is the service in Azure DevOps, which is all about packaging your applications and storing versions of packages. You might have heard some announcements around that. We've updated the pricing, so it's consumption-based pricing now rather than users, which is great. And there's free tiers as well, so you can use Azure Artifacts for free. Just out of a bit of interest as well, Azure DevOps stores currently in Azure Artifacts 155 petabytes of artifacts. So this thing scales pretty well. And to put that in perspective, we were talking about it in the team, they did the math. If you think about that in 2 terabyte hard drives, you'd need 76,000 of those. Or if you go over to the other booth, there's a Azure box, I think it's called, where you can like bulk upload stuff. Those things are a petabyte, so you need 155 of these. It's like 3/4 of a 40-foot shipping container for the stuff that's in there. I found that interesting. It's not at all relevant to what I'm about to talk about, but I found that really great. The idea with the artifacts, the stuff that you build, the actual versions of your application, they really need to be immutable. So I've worked in plenty of organizations and spoken to plenty of teams where they will build version 1.1 of their application, and then they'll find a bug, and so they'll fix that bug, and then rebuild version 1.1 of their application. And now you have a problem. You have 2 artifacts that have the same version. Which one's which? Like that 1.1 version should always be a unique, immutable version of your application. If you need to rebuild, reversion it, 1.1.1. And that's really important for knowing what has been deployed where, for that whole provenance story of what work I was doing, what code was changed, what build was produced, and what release went into what environment. You can follow that all the way through. If you can change those builds after the fact, then you just don't know. So that's really, really important. That also means that you need to externalize your configuration. So when you deploy this same artifact to your test environment, and then your QA environment, your staging environment, and your production environment, you need to know, or you need to be able to make changes. Obviously, the database is not going to be the same in your test environment as it is in your production environment. But if that connection string is hard-coded in your code, it means that you need to rebuild the application. And so suddenly you're not testing the same thing all the way through your environments. So any changes to the way the application works need to be externalized from that build so that you can maintain this immutable artifact. Right? And whether that's configuration files, app settings, I don't know, environment variables, or even stuff in the database. It doesn't really matter as long as it doesn't affect that immutable build. So that's important as well. And this really leads to deployment consistency, and that's what we want. When we deploy this artifact, this set of binaries that you have built to an environment, and then you promote it to the next environment, you don't want to rebuild, end up with different code, and you're deploying it to a different environment now. You want to be able to test the same thing through all your environments. So by the time you get to production, you know it's going to work because you've deployed it to the same kind of environment like 3 or 4 times before. Right? There are no surprises. All right. Final part of Azure DevOps is Azure Test Plans. And this one is really all about testing your application and making sure that what you actually produce and what you put into production is as safe and as good as possible. So in terms of testing, one thing that we found that's really valuable is automating as much testing as you can. And again, this pushes against a lot of organizations' cultures where they have a QA department and they have in their heads that they absolutely need a human to press that button or a human to copy those files over. It's fine if you deploy automatically to staging, that's all right. But when we get to production, we drop all of the automation and we do it manually. Now, this is definitely an anti-pattern, doing it like that. You have proven that your deployment works all the way through to this pre-production environment, and then you scrap all that work and you introduce human error to do that final stage, the most important stage. The other thing that frequently happens is they require somebody to actually do that work at the end, or hit the button to say, yes, we have gone through and we've tested all these things, and we're going to deploy to production. And you'll find that 99.9% of the time, it just gets deployed to production. Nobody's really adding any kind of value in that final step. They're just hitting the button to go to production. So why not automate that? The Azure DevOps team itself over the last 10, 12 years has moved a lot of their manual testing, in fact, almost all of their manual testing over to unit tests. And it took a long time, but it means that they're following a lot of the stuff that I've mentioned here. All of their tests are automated. They will pass all the time. They run 85,000 unit tests for every single pull request in their short-lived feature branches. So they know that these things are going to work before it actually goes to master, and they're running 85,000 unit tests. It's all automated. They don't need to worry about human error in this case. The other thing that's important is that all of the tests pass all the time, otherwise it doesn't get to production. If you have a test that fails some of the time, that is worse than a useless test. It's worse than having no test at all, right? Because if you look at it and say, oh, well, some tests fail, but that's fine, then what are they doing for you? They're not testing anything, right? They're just giving you a false sense of security with code coverage or something like that, right? So that all the tests must pass all the time, otherwise it doesn't get through to production. And then finally, one thing I just want to point out as well is if a bug makes it to production, that's not just a failure in the code. That's not just a bug you've introduced in that code. That is a failure in your whole pipeline. Right? What that means is that there should be something in your pipeline, whether that's a unit test, whether that is an additional step in your build or deployment pipeline, should be something in that pipeline to prevent that from happening again. So we've all heard in terms of testing, or many people have heard of red-green refactor. So rather than just fixing a bug, you write a test to prove that that bug exists, then you fix the bug, and then you run the test again and make sure that it now goes green. So now you have a test over that stuff. You know it's not going to go wrong next time. You can do the same thing with your pipeline. If you've deployed something to production and it's broken, fix your pipeline so that it won't happen again, and now you have coverage over that thing. You know it's not going to happen next time. So anything that gets into production that's bad is a failure in your pipeline, not just in the code. All right, so there's just a kind of a whirlwind of stuff that I've dropped on you there. Hopefully some of that stuff resonated, and I want you to really think about this definition that we talk about. It's not just the products. That's just how I categorize this advice. It's the people buying into this idea of continuously delivering value. And it's all about value. So focus number one on the customer. It's a customer-centric thing or a user-centric thing to have real success in DevOps. A few resources as well. There is Azure DevOps itself on docs.microsoft. DevOps at Microsoft is an awesome resource, and it covers a lot of how we do it at Microsoft and the lessons that we've learned over the last 10 or 12 years. And we deploy 80-something thousands of times to Azure every single day using Azure DevOps. So that's really useful as well. And then I also have a Channel 9 show if you're interested in me talking to smarter people about solving problems as well, called the DevOps Lab. Finally, in the other section, just past the GitHub near the big glowing sphere thing, there are a couple of Azure DevOps booths, and they are staffed with people from the product teams. So if you want to know about Azure DevOps, the product, they are the people to ask. And lately, they are the people who are thanked quite frequently. They've actually been getting a lot of people going over and thanking them for the work they've done, which is fantastic. So I would highly recommend going and having a chat to them as well. I believe there's still a few more books here. There's some stickers there and there. And other than that, thank you very much for your time, and I hope you have a great day.